Hi, everyone. Welcome to the September 2025 webinar. I hope you're enjoying some of this tropical moisture we're getting from the remnants of Mario. I actually got some rain this morning. I know some other folks have, so hopefully you get some too. Coming up, astronomical summer ends on the September equinox, and this year that happens on Monday, September 22nd at 11:19 a.m. Mountain Standard Time. But we also keep track of the meteorological summer, and that runs from June to August. So for Arizona, this was the third hottest summer on record and tied with 1978 as the 12th driest summer. And we'll go to the next slide. There we go. Let's take a look at August. While July is statistically the hottest month for Arizona, the August rankings actually beat July rankings this summer. August was the second hottest August on record for the state. Just to remember, the hottest August on record for Arizona was August 2020. So now back to this year, August, most of our Arizona counties this month ranked with their second hottest August on record. The only counties that didn't rank for their second hottest, that was Yuma, that had their 11th hottest August. La Paz had their fifth, and then Maricopa, Mojave, and Yavapai all had their third hottest August on record. Statistically, Arizona is the wettest month for Arizona, but this year only Yuma County was above average for August, ranking as their ninth wettest August on record. The eastern counties were much drier. Graham County had their fourth driest, Santa Cruz had their fifth driest, and Cochise and Apache counties had their eighth driest August on record. Then looking at the summer, so June, July, and August, Yuma won again as the wettest county for summer rankings. They had their 15th wettest summer on record. Santa Cruz was the driest county this summer, ranking with their second driest summer on record. Now let's take a look at the last 12 months. The map is showing the average temperature rankings from September 2024 to August 2025. So adding all those months together overall, statewide, this was the third hottest September to August on record. Looking at the charts, you'll see statewide rankings for each month. Last year, September, October, December, each ended with their record hottest for the state. Only 2 months of the last 12 were above average. Those were November and January. This map is showing precipitation rankings for September 2024 to August 2025. Statewide, the last 12 months ranked as the second driest September to August on record. Which one ended as the driest September to August? That was September 2001 to August 2002. Now, back to the charts. If you put together December and January, that was the driest December to January on record for the state. FYI that the driest December on record for Arizona happened December 2017. It was so dry that there was no measurable precipitation anywhere across the state that month. So then let's head to our water year records. Remember that a water year runs from October to September, and that's the calendar used to manage water in the United States and Canada. So then after an exceptionally dry winter, a somewhat moderate spring, and now a dry summer, Arizona currently has its second driest October to August on record. The driest October to August on record, that was water year 2002. Right now, Arizona's water year is sitting at 50% of long-term precipitation. Looking at the map, that's showing rankings of precipitation from October to August for different weather stations across the state. Most of the gauges are showing in their top 10, even their top 5 driest water years to date. The only wetter months so far this water year Those were the two statistically driest months of the year, May and June. So now we're looking at short-term drought maps for the last couple of Septembers and then the current short-term drought map. Going back to September 2023, looking at that short-term drought map, we were coming out of a very wet winter in 2023, and that was followed by a dry summer. So you can see how moderate and severe short-term drought expanded in central counties, and then extreme short-term drought built in southeastern counties. A similar expansion happened in September 2024, where winter 2024 was slightly wetter, and then moderate drought expanded in western and central counties from a dry monsoon. The southeastern counties persisted with severe drought. The current short-term map shows that every location across the state is experiencing some measure of short-term drought, and severe short-term drought is covering 57% of the state. Extreme short-term drought is 32%, and exceptional short-term drought persists in Cochise and Greenlee counties with 2% of the state. We assess long-term drought in Arizona using the Standardized Precipitation and Evapotranspiration Index. And that takes into account not only the lack of precipitation, but also the hotter temperatures that lose water from the soil. Looking at the past 5 years, that's what you're looking at here, you can see that Arizona has been significantly hotter and drier than normal. So let's take a look at what's been going on with the monsoon. So comparing the full monsoon 2024 to monsoon 2025, just up through Tuesday, looking at those maps, we're fortunate to see a bit more precipitation this monsoon, especially in the western counties. Hopefully we can capture a bit more before the end of the month, but we'll have to wait and see. And it's really important when we're looking at most of Arizona going back to normal amounts. Remember that too much precipitation on dry soils, that's the recipe for flash flooding. Looking at wildfire data up through Monday, there have been fewer total numbers of wildfires compared to last year at this time, but more acres have burned this year compared to last year at this time. For the when we're looking at these kinds of things, let me see if I can get the information out there. There we go. So as we start to think about winter precipitation, it's helpful to understand how summer and fall conditions affect winter conditions. When we have a wetter monsoon season, it's not so much that a wet monsoon adds to our water supply. Instead, a wetter monsoon helps moisten the soils. And what that does is it helps with a more efficient runoff for winter precipitation. Currently, looking at the last 30 days, we're showing very low amounts of soil moisture in Arizona. So now looking at some of the outlooks. For the end of September, the CPC is giving a more active end to the month and up to the start of October. The CPC is looking for troughing along the west, and that means the potential for storms. So that's why we're seeing that green show up on the precipitation outlook. Remember, this is just an outlook and it's not a forecast. So we'll need to pay attention to our local National Weather Service offices as we get closer. For October, the outlook for Arizona shows warmer conditions, but then equal chances for precipitation in October. October statistically starts to dry out for Arizona. So then if we pop into the November, December, January outlook, you're seeing a more likely chance of a dry winter. So we're going to look at the next slide to see how ENSO is playing a role in this outlook. And there we are. So ENSO neutral conditions are currently being observed within the equatorial Pacific sea surface temperatures, looking at those anomalies. And that means Neither El Nino or La Nina is currently the status. However, for October to December, there's a 71% chance that La Nina develops. La Nina for Arizona winter is statistically drier. And right now, there's a 33 to 50% chance for a drier winter for Arizona. So we'll have to keep our eyes on it. But now I'd like to introduce our guest speaker, Michael Graves, ADEQ. Michael does a lot of things for the state. He's been at ADEQ for, what is it, almost 11 years. You have a team of 3 other meteorologists, and I'm excited to hear your talk. So I'm going to go ahead and see if I can stop share and get you on here, Michael. And I'm excited to hear your talk.
Thank you so much. Let me share my screen here. Mm,
I know we all wait for the tech, right?
Right. Can you see this?
There it is. You are up and it looks great. Thanks.
All right. Thank you so much. My name is Michael Graves. Like you said, Aaron said, I'm an air quality meteorologist with ADQ. And I'll talk about the main things that I do. So I titled this presentation with the two main things that I do: air quality forecasting and smoke management. Um, But you'll see that here. I'll talk about a couple other things. I'll talk mostly about air quality forecasting, but I'll also talk about wildfire smoke and smoke management in our flag program. And there's a picture of me doing an interview, media. Whenever there's a air quality story, they'll often reach out and we'll do interviews. So that's one thing that I've been doing a lot more lately and growing in that. So the two main pollutants that we forecast for are ozone and particulate matter. When I say ozone, I need to make sure that people know that we're talking about ground level ozone, because most people, when they think about ozone, they're thinking about the ozone in the stratosphere. That's the good ozone. That's the ozone that protects us from the UV radiation. But ozone at the ground is a different story. It can cause health issues for people, especially people with respiratory disease and like asthma or COPD, people that are active outdoors. Um, Ozone. It's invisible. You can't smell it, can't see it. It's gas. It needs sunlight to form. It's not directly emitted into the atmosphere, but it actually forms when you get nitrogen oxides and volatile organic compounds. Those both come from vehicles, I think power plants, industrial activities, even plants can emit VOCs. When those combine in the presence of sunlight, you get ozone. And then we also, with particulate matter, we're looking at both PM10 and PM2.5. PM10, think dust, that's particulate matter that's 10 micrometers or less in diameter. And then PM2.5 is 2.5 micrometers or less in diameter. So PM2.5, think about smoke. And both of those also affect health. Think whenever there's like a dust storm or blowing dust, you'll feel it in your eyes, your nose, your mouth. And of course, if you have breathing problems, it can affect the way you breathe, affect your lungs. So both ozone and particulate matter can affect the lungs, the breathing, and even the heart. And so for the public, we don't talk about the usual units. So ozone is measured in parts per billion, and particulate matter is measured in micrograms per cubic meter. That's quite complex for the average Joe. And so EPA has this air quality index that takes those concentration and it puts them on this easy intuitive scale. So 0 to 50 is good, 50 to 100 is moderate, and then above 100 you get unhealthy for sensitive groups. Above 100 is when you exceed the health standard. So anything orange and higher, you're exceeding the standard, and that's when we issue high pollution advisories, which I'll get to later on. And so when it's good, it's good. And also, this table doesn't show you the general health effects that you might expect with these. So yellow, if people who are unusually sensitive to air pollution, they might consider adjusting their outdoor activities. And then as you go further down the scale, it starts to affect the general population. So air quality forecasting, it's not magic, but we're looking at the air quality observations. We got monitors around the valley for ozone and for PM10 and PM2.5. That gives us our current state of the air pollution around Arizona, but this map just shows you Phoenix. And then the air quality meteorologist's job is to take that and then predict how is that picture going to change in the future based on current weather observations. We're looking at weather forecast models. We're looking at human behavior that we expect throughout the day and typical trends that we see between night and daytime, and also between January and July, how um, human behavior can vary throughout the year, and as well as daily and seasonal pollutant characteristics, as in what's the average ozone level on September 1st? What do we expect, kind of the background, and then we take the current situation and how might the current situation vary from what we might see on average. Taking all that into account, then we put out a forecast. And so here's an example of our Phoenix air quality forecast that we put out. We forecast Monday for 5 days out. So this one would be this example you see was issued on Wednesday, and then it goes Wednesday, Thursday, Friday, Saturday, Saturday, Sunday. And then we're forecasting for ozone, PM10 2.5. We're looking for each hour of the day. So we used to only forecast for the air quality index for one value for each day. But one value, it's hard to see. You can't really plan your day with just one value. So when we started forecasting hourly, you can see that, oh, in this example, PM10, it's expected to be highest in the morning and it's better in the afternoon. And so if I'm sensitive to PM10, I might want to do my outdoor activities in the afternoon, provided that it's not too hot outside or. And then on the next page, we also have a table that gives you the air quality index for each of the pollutants for each of the days. Then we have a forecast discussion explaining the values. And then I'll talk about the flag program later on in this presentation. But yeah, this is the high push advisories are the biggest message that we send out to the public. Whenever we expect ozone or PM10 or PM25 to exceed the health standard, we'll issue a high pollution advisory. That's when the pollutant is expected to be higher than 100 AQI. A few years ago we instituted the high pollution watch, and so that's when we're expecting it's beyond day 2 or day 3, and it's kind of similar to think of the weather services watches that they put out. It's when we're expecting conditions to be possible for these pollutants to exceed the standard, and it gives the public a lead time. So we're expecting the pollution to have a potential, but wait, and we might upgrade it to HPA when we get closer. Um, So we have forecasts for Phoenix and Western Pinal, Yuma, and Tucson. For each of those areas, we forecast for ozone, PM10, and PM2.5. And so this map shows the locations of all our forecasts. And then on the right side, we have smaller forecasts or smaller locations where we just forecast for one or two of those pollutants. So the ones on the left are our biggest forecasts. And so our team, we rotate between all these forecasts. So it's not one of us doing all of these locations, but we're rotating, we're sharing all of these. So that helps. Daily pollutant characteristics. And so I'm going to just give you a few tidbits of air quality forecasting, things that stand out. And so ozone is typically going to be highest in the afternoons. And so that graph shows you ozone is highest in the afternoon, lowest in the mornings and evenings. Ozone needs sunlight to form. So that's why it's highest in the afternoons typically. But PM10 and PM2.5 in general are going to be highest in the mornings and evenings. And that's because of the local activity, but also because the inversion, it's more stagnant during those times of the day. Then when the day heats up, there's more mixing. Your inversion rises, your mixing layer rises, and so there's more winds and mixing that occurs that allows those pollutants to be more dilute in the afternoon. So these are your general daily pollutant patterns that you might expect for ozone, PM10, and PM2.5. So yeah, they're the highest points at times of the day. And so when it comes to ozone forecasting, internally we call it the ozone plume. So throughout the day, if you're familiar with the Phoenix Valley, we have this Phoenix wind valley circulation. And so in the mornings, your winds are going to be out of the east, and then in the afternoons, the winds shift to out of the west. And so, think in the afternoon, those westerly winds are pushing all the ozone that's forming in the valley to the east. And then also that ozone is rises up the higher terrain, so we typically see the highest ozone levels in the valley in the east, northeast parts of the valley. This is like the just a general kind of the standard expectation that okay, ozone's always going to be highest in this part of the valley throughout, especially in the summertime. However, we do get certain weather patterns like the Four Corners High during the monsoon when we're expecting active monsoon days. That can actually push the ozone to the west or into the central parts of the valley. So that's when we will see the highest ozone levels in that part. So that can change. For PM, the inversion plays the biggest role, and that's a layer of warm air that acts as a lid that traps all the pollution near the ground. So the air right above the ground cools faster than air above that. And so every night this happens and that you get that inversion. And then it gets stronger during the winter time as the air is colder. So the inversion strength is stronger and it lasts longer. It cuts off the winds above in the free atmosphere. And then so all that pollution that can form from local activity just gets trapped in there. So here's the brown cloud you might have heard in Phoenix. This is from the top of Camelback Mountain in November a few years ago. And you can see the inversion acting as that lid, trapping all that pollution near the ground. And you also got the Estrellas in the background there in South Mountain that act as sides for this bowl, this valley. So the pollution gets trapped on the sides, it gets trapped on the top. And so this is why typically see higher particulate matter levels, especially PM2.5 in the cooler months, because the inversion is stronger and it's trapping all those pollutants in the ground. So here's a time lapse of New Year's Day 2016 showing you the progression of the inversion or that brown cloud throughout the morning as it starts to rise, it warms up, it gets more diffuse. All that pollution is rising. So New Year's Day is going to have all that fireworks smoke and even fireplace smoke. Gets more diffuse in the afternoon here. And then as the nighttime comes, it settles back down again. So, the big four, Christmas Eve, Christmas Day, New Year's Eve, and New Year's Day, we can typically see the highest PM2.5 levels in the year. And so here's a graph showing you from the year from January 2017 really to the end of the year. And there's PM2.5 levels. This is the daily value, the daily average. And you can just see how those 4 days just basically blow all the other days out of the water just because of the fireplace usage and the fireworks. And so those are the big four. If weather is supposed to be stagnant, there's no winds or no rain, we typically expect those holidays to see really high levels. So now we'll move on to the flag program. This is an extension of our air quality forecast that we put out. And so schools and organizations can sign up, we'll mail them flags, and they'll fly a flag based on our forecasts. And so we have a green flag, yellow flag, and an orange flag. So whenever we issue high pollution advisory, that's the orange flag. Schools, they'll look at our forecasts in the morning, and then they'll ensure that correct flag is flying, and then it can indicate how students and staff and even surrounding community might want to respond and to the air quality. They can stay inside, have students stay inside if for a recess if they are sensitive or something like that. And so at the bottom, there's our forecast. They'll sign up, they'll look at our forecasts, and that's where the flags mean. What flag do I fly? Fly the yellow flag. We want to make it as simple and easy as possible for that. So for our flag program boundaries, these are based on our four biggest forecasts that I showed you, Phoenix, Yuma, Tucson, and West Pinal. Those are the areas that have what we call non-attainment areas or areas that have not met EPA's standards. And so these are the areas with the highest populations and also the areas that have the air pollution problems. And so that's where the flag program boundaries exist. And so any school, business that's 50 employees or more, nonprofit and government buildings in these areas can sign up for our flag program. And so I just told you all that. So there's a slide telling you all who can participate in the flag program and also tribes as well. Schools make up the majority of our participant base, probably about 90%. Schools will apply the flags based on their facility and their capacity, and it's fun to see how they use it. They can put them on flagpoles, hang them on the walls, hang them on fences. We also now have digital flags that schools can put on their marquees, and we have even smaller pennant-sized flags that are suitable for desks or windows. And so the purpose of the air quality flag program is for air quality awareness. So the general population, if you're not affected by the air quality, you're probably not going to be thinking about it. So it's also good for the general population to be aware of the air quality too. So the other thing that we'll do is wildfire smoke forecasting. And so we're always watching for wildfires and wildfire smoke around the states. Traditionally, the wildfire season, I think late spring through September, but now these days that wildfire season, it could be any time of the year really. Um, and so like this past year, we had a wildfire in December, January. So whenever we see a wildfire and we're expecting smoke impacts to be significant enough and prolonged enough, we will coordinate with the Forest Service and we'll put out a forecast. And this forecast will be focused on the areas receiving the highest impacts of the smoke. We'll also have a little map there showing you the general expected plume behavior. And this forecast will be daily until we expect impacts to quiet down. And lastly, smoke management. And so this is based on prescribed fire. And so these are planned wildfires conducted by federal state land managers. So the Forest Service, Bureau of Land Management, you got state forestry, Department of Defense as well. And the purpose of prescribed fire is they're improving the forest health. Reintroduces better nutrients into recycles the nutrients in the soils, and as well as reduces severe wildfire risk as it thins out the forest and thins out those fuels so you can better control wildfires as well. They're called prescribed fire because these fires only occur in certain prescription for weather and fire behavior conditions. And so you need those specific conditions to burn. And we got pile burns and we got prescribed broadcast burns. Pile burns is when they pile up all the material and burn. And the broadcast burn is where they light the landscape and let it run. And so we have a rule, our smoke rule, where federal and state land managers that conduct prescribed burns have to go through us and we approve the burn. So the whole process of the prescribed burns it takes years to where they have to plan it, they have to they have this huge burn plan on their side to come up with the conditions for these burns, and then at the very end, when they burn, that's when they come through us, and then we're looking at weather conditions, temperature, moisture, winds, and we're also knowledge of the fuels, and we're trying to minimize smoke impacts. There's always going to be smoke from wildfires, but our goal is to minimize those impacts with coordinating. We're going to coordinate with the burners, and then they'll also use their own emission reduction techniques. And so piles are one of the main ways that they as a emission reduction technique, as in the pile will draw in the air and it'll kind of burn and help consumption as well. And piles burn are more in the wintertime. So because the wintertime there's snow on the ground and they can control the fire behavior better with those. And so smoke forecasting is similar to air quality forecasting. We're looking at a lot of the same tools, but we're also looking at drainage. So daytime, it's the winds, and at nighttime, when that inversion sets, smoke settles on the ground and acts as like a liquid in the terrain. So it can be very tricky, and we got to watch where the train is flowing and see if the train can direct smoke into communities or not. And so that's one thing that we'll watch out for. We can model, and we're looking at Google Earth a lot to look at those drainages. And so just an example last year, this is a map showing all the burn requests that came in. And so you can see that we get over 400, 500 requests throughout the year. And October, November is what we would call the big season. That's when we get the prescribed the broadcast burns because weather conditions are cooler better for fire behavior. It's after monsoons as well. And then lastly, we're always learning, and so we're always seeking to get better at our forecast. Whenever we miss a forecast, we're going to look back and see what we did wrong or what we could have done better. Like why was dust higher last night? Was it from an outflow that we didn't see or weren't expecting? Or why was ozone higher than expected? Why was it lower than expected? And we're also often doing research projects and case studies, just trying to understand better. So these are a couple of projects that I did in the past, like can spring Enso predict summer ozone, or does the agriculture around Yuma enhance Yuma's ozone? And so we're always trying to understand the synoptic and mesoscale situations to better understand. Because ozone, we're always learning. Ozone is very tricky. So that's really all that I have, and I can answer any questions people might have.
Thank you so much, Michael. That was
Mhm.
excellent, and we really appreciate your service to the state.
Thank you.